get flask number 2. Sorry, this is really up close and personal. I am kneeling on the floor so that I can actually look at my graduated cylinder. So now let's pour 15 for this one. Right around there. Let's drop her some more in. Slightly under, but I think that one will be fine as well. So let's add it in here. Let's actually make sure to get the spout on the right side. So that one is going to slowly seep down in there. There we go. Try to get that last little drop in there. So there is 2. Let's do the same for 3. Now, if you'll notice, I am actually squeezing everything out and then tapping my pipette before I take it out. That's just to reduce how much we'll get on the countertop. You don't want to leave chemicals out and about. So this one's actually gone a little bit over, but it's not a full milliliter. It's about half a mil. I'm going to take it. I think it's fine. Like I said, what we're more worried about is making sure we got all of our copper in and making sure we have a very, very accurate measurement for that. Everything else should be in excess, just so that we know for sure that we will get this royal blue color instead of this very light color. Let's give that a little help. Here we go. So there's 3 done. Let's do the same for 4. Okay. That's pretty much spot on. Let's add it in. Now this one, you can very clearly start to see that it is much, much less saturated than the others. These 3, it's kind of hard to tell if one is more saturated than the other, but this one is very, very clear. So, number 5, very first thing we add to it is going to be our 15 mils of ammonia. So this one is our blank. It should have absolutely no copper in it. If we hadn't rinsed our funnel before this point, we should have, so that we have absolutely no copper at all in it. This one should just be ammonia and ammonium chloride. So see, perfectly clear, as the ammonia solution was. Okay. So that was our ammonia. We will need that again later. Now I'm going to grab the ammonium chloride. And we're going to do the same thing for it. We're going to try to pour about 15 mils. Just to plop it in there. Just so we know for sure that we have plenty of this ammonia in there. That's pretty close. Okay, so here goes the ammonia in this one. excuse me, this is the ammonium chloride. And our color completely went away in that one. It's just very faint now. I'm wondering if I put a little bit more of the ammonia, if it would come back. So let's actually take this ammonia. That's quite interesting, and I'm guessing that that is exactly what happened with the 1411 sections. I think what I am going to do is I think I am going to omit the ammonium chloride. I will remake this one. I should have plenty of the copper solution already just to remake this one without the ammonium chloride so that we still have that really bright blue color. I'm wondering if it's how I actually made the ammonium chloride, but really it should have, it should be fine. I think we're just going to omit the ammonium chloride for right now. So I will be back. I'm going to remake this first one. Okay, so I have remade that, and of course my updated amount will be included instead, because this is what I will go forward with for the absorption. So now I'm going to omit the ammonium chloride so that we keep this color so that we can actually have some absorbance. So I'm just going to top all of these off with DI water. So and of course we want to use a pipette to very well control how close we get to the line of our volumetric. There we go. Okay. I think this one may be harder to see on the screen. Here it goes. You can actually see it now. Slightly under. So these are not supposed to be this light color. You can probably see that it's gone a little bit thicker than we really want. Let's see if giving it a little plug will help. I expect that to be a problem. Really, it should be this color over here, and it should still be that color even when we get to this stage. I will be back. I'm going to see if I can figure out what I can do to make this stay that color. Okay, so it took me a few minutes and I had to get a dropper bottle of more concentrated ammonia, but I finally got them to look the colors that they are supposed to. Now, I want to note that just about all of these are slightly off of their volumetric flask markings. Ideally, you want them to be perfectly on there. So, another point of error that you can talk about in your report is that all of these are going to be slightly off from the concentration that you will calculate based on the amount of copper sulfate that we added and the volume. The volume should be 50 milliliters exactly, and that's what you should still use to calculate because we did use a volumetric flask. But looking at these samples, you can tell that they are not at their volumetric lines. So that is a source of error. I did not want to completely restart and remake a new flask of copper solution. So I went with what I already had. That couple of milliliters shouldn't make a huge difference, but it will make a difference. So you could just talk about that in your report about the error. So now that all of the solutions are made, we can actually go to filling our cuvettes. So I'm just going to take 5 cuvettes, place them in this tray, pop the tops off of each one of these. I'm going to keep these in the same order as my volumetric flasks so that I know exactly which cuvette has which sample. I can get the top off of this one. There we go. There's 3. And 4. And 5 is our blank that I did not add any ammonium chloride to. Let's see if I can get the cap off of this one. Give me a second so I can get the cap off. Okay, so I've gotten all the caps off. I've got the caps off of my cuvettes, and I've also stuck my pipettes into my volumetric flasks. So I'm just going to fill up my cuvettes in order. So that's about 3/4 for that one. It's about 3/4 for that one. It's about 3/4 for that one. I don't think I quite got enough. There we go. That is about 3/4 for that one. And our blank. A little bit more. Okay. So now I can plop all the tops on. Oop, get my gloves stuck in them. Now, it may not be super apparent to the naked eye which one is which, especially with this smaller frame, smaller mass. But let's go over to our spectrometer. So here is the spectrometer. Now I am going to get both my laptop and this desktop here set up so that we can very quickly get this set up, take our measurements, and then we can do our unknown. Okay, so I have my samples set up. I have taken my gloves off, but I have wiped these down, and I will very carefully grab them and put them into the UV Vis without getting fingerprints on the sides that do not need fingerprints. So I have the program on my computer here, and it didn't prompt me when I first started it, but I'm going to calibrate dark. And with that, you want to actually put your hand over the box and press the button. So I'm actually going to do that with the hand that I'm holding my phone with, so that it will actually calibrate. Okay, so then you also want to take your hand off and calibrate light as well. Uncalibrate. It's done calibrating that. So now I should be able to take my first sample. My first sample is just going to be sample number 1. Plug it in. Let me see. Analyze a graph. Analyze solution. Let's see here. So there's a little button down here. This should be where we start. I've already calibrated, so it's going to go ahead and start that. So it looks like our solution is very, very low, which this should be our highest solution. This is kind of odd, but we want to look in this visible range. So let's go down. This kind of looks like our tallest peak. So if we do triplicate, didn't want it to go away. I did not want it to zoom either. Well, that makes it a little bit easier to see our peak anyways. I don't know where my cursor went. Let's see if we can get one back. There we go. Okay. Okay. The computer has decided to turn off because of course it has. Bleep. Bleep. There we go. Okay. So I have this set up. So while it's running, I'm just gonna type in a few of the values. So I saw, gotta let me, 0.150, excuse me, 0.150, and I'm also seeing, I saw 0.147 several times, so 0.147. Let's see what another one. Maybe 0.144. Okay. So, and of course, I don't like for it to have, oh, that's not, the alignment's not what I want. It's the decimal. There we go. I want 3 decimals. So now, I am going to take out the first sample. I'm going to plop in the second sample. We should have our peak in the same place. So now we're seeing absorbance in around 0.135. So 0.135. Zero 0.133. Maybe 0.136. So even though they look very similar to us, you can see that there's an obvious trend already. So now let's take out this one and put in the next one. Our peak should still be at the same place, and you can see that it's drastically decreased. So now we want maybe 0.092, I believe, is what I saw. Don't want. There we go, 3 decimals. I saw 0.090. Let's do 0.093. So now let's take this one out. Go to solution 4. Even still, even lower. So I'm seeing 0.040. .038. Let's see what else we got. Let's do 0.042. And let's plop in our blank. Now, for our blank, we want to leave this exactly where it's been. So, yep, still definitely a difference. So let's do 0.032. And then let's do 0.034. And I saw a 0.029 in there. So let's take that one. So now, these are our triplicate measurements. So up here I have triplicate 1, 2, and 3, or our sampling 1, 2, and 3. And then this is our solution number. So now, let's go make the unknown solution. Okay, so we're back at the balance. I'm gonna weigh out somewhere between 0.1 and 0.25. So let's see. That is actually just slightly under 0.1. So we're gonna add a little bit more. .17. Not 0.18. Let's back away for a second. .1801. That's what we'll go with. So just for time, I made the unknown off camera. So now I'm just going to get some, put it into my cuvette. Maybe a little bit more. That's enough. Put the cap on that. Want to get a chem wipe and wipe it off. And we will take it over here. So let me get everything wiped off and ready to go because the computers are asleep now. Okay, so I have plopped our unknown in and it is reading . 0.144. 0.147. And 0.146. So I will recanoodle all of this so that it is a little bit easier to read, and then I will send it out. Here will be your data. I will also put the masses and volumes on this spreadsheet. And yeah, that should be everything. Now I'm just going to clean everything up. Bye guys. If you have any questions, you can email me, you can email your TAs. You just want to take your averages of these numbers and then plot them against the concentration that you calculate based on the volume and the mass of our copper sulfate. Bye-bye.